Life begins with an impulse. Every thought, every movement, every feeling is a flash of electrical signal. But there is an enemy that can destroy these natural mechanisms. It acts quietly, imperceptibly, and inexorably, destroying us from within.
We're talking about microplastics, tiny particles that can't be seen with the naked eye. They're much thinner than a human hair, extremely fine.
Not just a pollutant, not just a toxin. It is a material that destroys the language of life itself. But how does it do this? Once the impulse is disrupted, reality begins to distort. Plastic particles break the connection between cells. They trigger self-destruction programs. They deprive cells of energy.
And it is frightening to understand, and increasingly so with increasing scientific studies, that nanoparticles at nanoplastics, as they get in, are actually damaging the mitochondria, that energy-producing part of the cell.
Nanoplastic continuously drains our power from within. Our future has already changed. We just haven't realized it yet.
From the molecular level to the scale of entire ecosystems, understanding microplastics is crucial for protecting the biosphere and public health.
Are you ready to find out what is happening to your body right now? Watch the documentary, Nanoplastics, Threat to Life. During pregnancy, a woman's body creates ideal conditions for the growth and protection of the fetus. However, even the placenta, the body's primary barrier between mother and child, cannot stop plastic nanoparticles from crossing through. A research team led by Antonio Ragusa made a landmark discovery when they detected microplastic particles in the human placenta for the first time. Their findings showed that plastic can penetrate a place where no artificial material had ever been found before. The very environment where new life begins.
I was in a wonderful place in Italy, in Sardinia, a place called Piscinas, in Sulcis, in the southwest of Sardinia, where the old mining areas are. It's a very remote, beautiful spot where there's nothing around for 6 or 7 kilometers. While I was walking, I suddenly saw these bright, colorful, sparkling things on the beach. I asked my wife, "What is this?" She looked at me a little puzzled and said, "Well, it's plastic." I said, "Plastic? How could plastic get here when there's nothing for 7 or 8 kilometers in any direction?" She looked at me again, with an expression that made it clear how little I understood, and said, "It comes from the sea, of course." And that's when something clicked in my mind. If plastic can spread through the ocean and end up in such untouched places, then it could also reach the inside of the womb, and so inside the bodies of babies. Naturally, from that intuition, I started pursuing this line of research. I'm a gynecologist. I help deliver babies. So I knew about plastics as much as everyone else, until a certain point. But I began reading and studying, and I reached out to some scientists who worked with microscopes. One of them was a brilliant professor working on the opposite side of Italy, in the Marsh region. She used a Raman microscope. A Raman microscope allows you to examine tissues and determine whether they have plastics inside them. Now we call it plastics, for simplicity. But of course, the term plastics covers a wide range of materials. There are dozens and dozens of different plastics. Let's say they are tiny pieces, polymers, that is, infinitely repeated tiny pieces of certain materials that we use every day, throughout the day. So we sent placentas to this professor, and she did an excellent job. She was able to locate and identify plastics inside placentas for the first time. The article we published in 2021 caused a bit of a scandal because the idea of plastics inside the placenta inside our babies was shocking to people, because the plastic we find in the oceans is the same plastic we ultimately find in children.
Plastic triggers inflammation and disrupts blood flow in the placenta. This means the fetus receives less oxygen and fewer nutrients, increasing the risk of intrauterine growth restriction, hypoxia, and preterm birth.
The more plastic there is in the placenta, the more likely it is that babies, unfortunately, are born prematurely. And these babies also tend to be smaller compared to those with lower levels of plastic exposure. We have to recognize that premature birth is the main problem facing humans today. In Italy, it's about 7%. In the United States, where the healthcare system is clearly less effective than Italy's, 12% of babies are born prematurely. So, in this sense, an increase in this number would mean an even greater burden for humanity, biologically, for families, and for everyone involved, and of course, economically, for those who care about costs.
We know that these particles can be taken up by these particles going through the placenta and then being found in the embryo, and therefore indicating that already in very early life we have an exposure also to the embryo.
The electrostatic charge carried by nanoplastics is especially dangerous in embryonic tissues, where even minor disruptions can lead to developmental abnormalities. In other words, nanoplastics begin harming the child's body even at the very earliest stages of its formation. Over the past 2 decades, physicians have documented an alarming increase in congenital birth defects. For instance, Chinese researchers have found that in China, the rate of such defects has nearly tripled. Similar trends have been observed in other countries. One of the fastest-growing congenital abnormalities in newborns is gastroschisis, a defect of the anterior abdominal wall in which loops of the intestine and sometimes other organs protrude through an opening in the abdominal cavity. The prevalence of this defect has increased over the past 3 decades. For instance, in the United States between 1995 and 2012, the percentage increase in gastroschisis ranged from 68% to 263%. An increasing number of children are also being born with hypospadias, a condition in which the urethral opening in boys is located in an abnormal position. In the United States, the incidence of hypospadias has risen by approximately 17% over the past 20 years. A recent growing number of cases involving congenital heart defects, Down syndrome, and other developmental anomalies have also been reported. After birth, children continue to be exposed to micro and nanoplastic particles. Plastic baby bottles, food packaging, and toys are all sources of contamination. When a baby bottle containing warm water is shaken, up to 16 million microplastic particles per liter can be released. Hot water and sterilization further accelerate this process. As a result, infants are exposed daily to millions of microplastic particles and trillions of nanoplastics. Scientists have even detected microplastic in human breast milk. Research has shown that nearly 40% of breast milk samples, one of the most essential sources of infant nutrition, already contain hazardous plastic microparticles. Due to their higher metabolic rate and breathing frequency, children take in more air, water, and food per unit of body weight than adults. Consequently, at the same level of environmental contamination, their bodies absorb higher doses of microplastic. Moreover, the protective barriers in a child's body are not yet fully developed. This means plastic particles can penetrate tissues more easily and accumulate at higher concentrations. For example, in children under 2 years of age, the ethmoid bone is not yet fully formed, and its openings are wider, allowing plastic particles to pass more easily through the olfactory nerves directly into the brain.
Plastic is an infiltrator, and it's mainly children who are affected by it. In our scientific article that drew a lot of attention and was widely cited, we called them cyborg babies, meaning babies who are made of organic material, but also inorganic material like plastic. These babies are smaller. They generally have smaller brains, and very few end up with lower levels of plastic in their bodies. They're not completely free of it, since plastic is everywhere, but with lower levels of plastic.
Because of the electrostatic charge of micro and nanoplastic particles, as well as the presence of bisphenols and phthalates, the endocrine and reproductive systems of children are particularly vulnerable. These substances interfere with the formation and development of the reproductive organs, potentially leading to infertility later in life. Given scientific projections that by 2045 humanity could face widespread infertility, children born after 2020 may have a high likelihood of being unable to conceive their own offspring.
I have 2 little daughters, and for me personally, everything we have just heard is terrifying. The truth is that we still don't fully understand the catastrophic consequences of our children being exposed to micro nanoplastics. Or, as Dr. Ragusa put it, they have become cyborg children. We're only beginning to grasp the full scale of this reality. And it is truly heartbreaking to look at small children and realize that they may never be able to have children of their own. Not to mention that their lives are already at risk today.
The immune system is also at risk. In early childhood, it is still learning to distinguish between friends and foes. Exposure to microplastics can disrupt this process, increasing the risk of allergies, eczema, food intolerances, and even autoimmune diseases.
But it also has long-term consequences by which cell programming determines diseases that will then manifest themselves when a person reaches adulthood. That is, at 40 or 50 years of age. And these are diseases that are currently overwhelming, if not outright damaging, our world. They're the so-called non-communicable diseases: obesity, hypertension, diabetes, and metabolic syndrome.
A child's brain is especially vulnerable in the first years of life, a critical period of rapid nervous system development when neurons are formed and complex neural connections are established. However, electrostatically charged nanoplastic can interfere with these delicate processes by inducing inflammation, damaging immature nerve cells, and impeding their development. As a result, memory, attention, and learning abilities may be impaired, and emotional instability can arise. Over time, this may manifest as anxiety, learning difficulties, and episodes of aggression. In addition, studies indicate a potential link between exposure to micro and nanoplastic and the development of autism spectrum disorders. Given the breadth of damage that electrostatically charged micro and nanoplastics can inflict on the human body, the scientific community may need to examine their possible role in the rapid rise of autism more closely.
For me as a father, it is heartbreaking to realize how truly defenseless our children are. Micro and nanoplastics start affecting them from the very moment of conception, persist throughout fetal development, and continue their impact after birth. Unfortunately, the illnesses that we have already discussed are not the only conditions that micro and nanoplastics can trigger in children. According to statistics, sudden infant death syndrome is among the leading causes of mortality in infants under 1 year old. This is when a seemingly healthy baby dies unexpectedly, and the cause remains unknown even after all examinations. The number of such tragedies is rising rapidly. In the United States, for example, the number of sudden infant deaths has increased by 12% between 2020 and 2022. It is unbearably tragic when there's no way to protect a child.
Since nanoplastics can cause chronic inflammation in any tissue they penetrate, they can disrupt the formation of neural connections even before birth, including in the regions of the fetal brain that control breathing and heart function. After birth, the damaging influence of electrostatically charged nanoplastics continues. An infant's nervous system is still developing and remains highly unstable. Therefore, even minor disturbances in signal transmission can lead to respiratory or cardiac arrest. These very functions are often impaired in infants who die from sudden infant death syndrome. Moreover, when micro and nanoplastics damage mitochondria, the affected cells begin producing less energy. To compensate for this deficit, they increase the number of copies of mitochondrial DNA and expand their population of mitochondria. Studies have shown that children who died from sudden infant death syndrome had a significantly higher number of mitochondrial DNA copies in their cerebral cortex compared with control groups, suggesting that this number may serve as a biomarker in cases of sudden infant death syndrome. Thus, exposure to micro and nanoplastics may be a key factor in the development of sudden infant death syndrome, as well as in a range of pathologies that contribute to premature infant mortality.
We're unable to protect ourselves, and worst of all, our children from the effects of micro and nanoplastics. While modern diagnostic equipment capable of accurately identifying the true causes of disease and death is still not available everywhere, we can say with high degree of confidence that nanoplastics contribute to the development of many illnesses and may accelerate their progression. In those rare cases where detailed postmortem examinations were conducted, researchers have found significant amounts of micro-nanoplastic particles precisely in the affected organs and tissues. For example, in brain tissues, atherosclerotic plaques, malignant tumors, and other pathological formations. But despite millions of deaths every year, such investigations into the presence of these plastic particles are carried out only in isolated cases. There are two main reasons for this. First, many laboratories simply lack the equipment required to reliably detect micro and nanoplastics. Second, doctors and researchers, they rarely consider the possibility that these particles could potentially influence the development or outcome of the disease. Consequently, medical reports continue to list familiar diagnoses, although behind them may lie an overlooked factor: the impact of micro and nanoplastics on the human body. I understand that hearing this part of our investigation may have been very difficult. It was for me as well, believe me. But the impact of micro nanoplastics on all of us is not something we can continue to ignore. This is a crisis already underway, one that remained unnoticed for so long because the threat has been working silently within. Every day, and I'm not talking about every year or every month, but every single day, the amount of micro and nanoplastics around us continues to increase. Large plastic waste constantly breaks down into smaller particles, and these particles eventually enter our bodies through the food we eat, the water we drink, and the air we breathe. This means that with every meal, every sip of water, and every breath, huge quantities of nanoplastics enter our bodies and begin their destructive work. Their harmful effects on our cells grow in direct proportion to their concentration. And this is a scientific fact. What's even more alarming is that today, there is already so much micro nanoplastics accumulated in the ocean that it will be enough to destroy the entire biosphere, including humans, at least 3 times over. When we hear about threats of such magnitude, our instinct is to run away from them. And I understand that. It may feel like the only logical response is to eliminate plastic from our lives completely, or better yet, to take our family and move to some pristine corner of our planet. But would that really solve the problem? In fact, where could we possibly go to escape micro and nanoplastics? Dear friends, and all those who care about the future of our planet, I'm speaking today in response to a recent publication on a widely respected media platform. In that article, certain scientific findings on the presence and dangers of micro and nanoplastics in the human body were called into question. Notably, the key arguments relied on comments from a specialist directly affiliated with a large corporation in the plastic industry. As a result, public discussions, attention, and resources are once again being diverted away from solutions and toward ideological debate. Whether intentional or not, such publications create a misleading sense of reassurance, the impression that things aren't as bad as they say. But questioning the danger of micro nanoplastics to human health and the biosphere is a huge mistake. Scientists today are not trying to scare anyone. Their conclusions are based on objective research that is meant to help the public understand the real risks. At ALLATRA, we have been studying micro nanoplastics for more than 2 decades. We're not funded by corporations, nor are we affiliated with politics or religion. And we call things by their proper names, regardless of whether it's convenient or not. So let me state this plainly. Micro and nanoplastics represent one of the most serious threats facing humanity today. A large and growing body of evidence shows that plastic particles have already penetrated the environment and the living organisms. And many peer-reviewed studies confirm the presence of micro nanoplastics in water, air, soil, and animals. This includes humans, where these particles have been detected in the brain, our hearts, our guts, placentas, and other organs. But the mere presence of these tiny plastics is only part of the story. Research increasingly indicates that micro nanoplastics trigger a range of biological effects linked to serious diseases, from metabolic disorders, reproductive dysfunction, to severe neurological problems. As evidence accumulates, the need to take this issue seriously becomes undeniable. And yet, it is concerning that scientific uncertainties are being used for political or for commercial purposes. Some demand a complete ban on plastic production, while others dismiss the research entirely as unreliable. Both responses drain resources and hinder genuine scientific progress. Thus, banning plastic production and destroying this industry is not the solution. Nor is the opposite, when corporations, acting to protect their business interests, attempt to discredit or downplay research on micro nanoplastics. Neither approach will solve the problem. The reality is that plastic underpins much of modern technologies, medicine, and industry today. Eliminating it outright would create a serious social and economic consequences without addressing the core issue. That is a vast amount of micro nanoplastics that already surround us. These particles will not disappear on their own. And right now, they pose a very serious threat to our health and the biosphere. This is precisely why it is time for us to move beyond confrontation, beyond bans on one side, and denial on the other, and focus on practical solutions. At ALLATRA, we propose a different path, directing efforts and resources toward a solution that, based on many years of research, we believe can truly mitigate the risks associated with micro nanoplastics. And the essence of this approach is straightforward: to deprive plastic particles already scattered across the planet, to deprive them of their most dangerous property, that is, the ability to accumulate and retain electrostatic charge. Experimental and observational studies indicate that the electrostatic charge of plastic particles play a key role in determining their biological activity. Thus, by neutralizing this property, micro and nanoplastics can become biologically inert, that is, no longer capable of causing harm to life, including to humans and on the biosphere as a whole. This is where society's efforts and investment should be directed, towards understanding how these particles interact with living systems, and toward developing safe and effective methods to neutralize the charge. To make this possible, scientists around the world who are studying micro nanoplastics need funding and opportunities for interdisciplinary collaboration. They need advanced equipment, shared infrastructure, and access to unified data platforms. The modern scientific community has already proven that it can achieve extraordinary results when we are united around a common goal. Recall the Human Genome Project. Hundreds of research centers, dozens of countries, unified standards, and the results that transformed medicine and biology forever. The plastic crisis demands a similar model of global cooperation. Only under such conditions can we refine methodologies, make critical discoveries, and find the solution that we need. Let me repeat that neither pressure on the industry nor dismissal of scientific research on micro nanoplastics brings us any closer to a solution. Regardless of the debates, plastics particles will continue to accumulate, and the threat will continue to grow. So this means one thing. The global scientific community, public funding agencies, and responsible businesses must urgently direct their attention and resources to the key task. That is to safely neutralize the electrostatic charge of micro nanoplastics. Only then do we have a real chance to protect our and our children's health, preserve technological progress, and safeguard our shared home, planet Earth.